This is Senior Algebra, Section 8.1, Radicals here. So today we're looking at square roots. In class we're going to look at cube roots, fourth roots. We'll also look today at the Pythagorean theorem just for a second, and then apply it in class with the distance formula. So we start with what a square root is. It's a positive. It says if a is a positive real number, then the square root of a is a positive, or the principal square root of a. The negative is the negative square root of a. Some things that we want to remember here. When I have the square root of a times the square root of a, that's the square root of a squared. Squared and squared cancel each other out, so I get just a here. So when I think about a number, the square root of 3 times the square root of 3, I could think of it as the square root of 3 squared, which is 3. When I put the square root of 3 times the square root of 3 together, I really get the square root of 9. Oh, what is the square root of 9? That is 3. So a couple different ways to think about that here. When I have the negatives there, I have a negative 1 out in front. So a negative times a negative is a positive, or a negative 1 squared. Well, it's just going to be 1 here. So I'm left with a. Again, a has to be positive. Okay, if it's negative, we get a non-real answer. We'll talk about that a little bit later. So in this one, it says find all of the square roots of 36. So we're going to look at the positive one and the negative one here. And we know that what times itself is 36? 6. So we get 6 and negative 6 there. Now, in example 2, they give us just the positive square root here. So the square root of 81 is 9. In the second one, we have the negative there. Okay, so notice there, square root of 81 is just 9 here. The negative, that's our second part, so it's really a negative 1 times whatever the square root of 1024 is. That'd be something that you would definitely use your calculator on, and you should get negative 32. The last one here, a fraction. Well, I can split this up. I can think of it as the square root of 4 over the square root of 9, which is 2 over 3. Now, in example 3, it says find the square of each radical expression. We have to be careful, what are they asking us to do here? In example 2, it was find the square root. In example 3, it was find the square of it. So we're going to square everything here. So the square root of 81 squared, the squared and the squared cancel out. We just left with 81. If I look at B, when I square it, I get 17. The negative times the negative is a positive here, so it just gets 17. And then in C, the square root of something squared is just what I had left inside. So x squared plus 4. In example 4, we want to identify each as real or imaginary. And if it's real, is it rational or irrational? So let's recall here, real and imaginary. Real. Okay. A has to be positive. Okay. And when we think about this, when we take a square root, what times itself is that number here? So if I look at A here, what times itself is 81? Well, we know that's going to be 9. So that is real. Now, is it rational or irrational? Well, we have to know what the definition of is. So a rational number is a number that can be written as a quotient with two integers. So 9 over 1, 9 is an integer, 1 is an integer. We do consider it rational. Things that you want to look at, things that go on forever without a pattern would be considered irrational. Now, if we look at B here, we have the negative in there. It is imaginary. It's not real, because we can't take the square root of negative 81. What times itself is negative 81? Well, can't do it. Because if it's a negative and a negative, I get a positive. Positive, positive, I get a positive here. So I can't do that. In C, I don't get an actual integer answer. I get this 9.055385, blah, 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 blah. Keeps on going forever. Okay, is that real? Is it the square root of a positive number? Yes. so it is real. Is it rational or irrational? And can I write this as a fraction with an integer on top and integer on the bottom? No, so it is irrational. The last one here, notice the differences between B and D. Where is the negative? In D, the negative is on the outside, so it's negative. Square root of 81 is 9, so negative 1 times 9 or negative 9. That's real, and it is rational. In example 5, we're looking for the decimal approximation, and we run around to the nearest thousandth. So looking at this, some things that you should be able to do here. Okay, what number is it going to be between? Okay, what perfect square root is it going to be between? Well, 2 squared 4, 3 squared 9, 4 squared 16. Oh, it's between 36, which is 6, and 49, which is 7. So I know the answer is between 6 and 7. You should have some idea how to get that. So when I type it into my calculator, hit the square root button, I get 6.2449979, blah, blah, blah. I want to round it to the nearest thousandth. What spot is that? Tenths, hundredths, thousandths, and I look to the 9 here. So I'm going to round up. Remember, 5 or up, we are going to round up. 4 below, we round down. In B, I get negative 2.828427, dot, 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 dot. Round to the nearest thousandth, 1, 2, 3 spots, and I look at the 4. The 4 is less than 5, so I just leave it. Negative 2.828. The last thing, reminder here, the Pythagorean theorem. We've looked at this before. You've seen it in geometry. Remember, we have A and B and C here. A and B are my two legs. My C is my hypotenuse, always across from my right angle. And we have the Pythagorean theorem. Around my room, we have a bunch of the proofs of the Pythagorean theorem. We've looked at a couple of those. So in example 6, we're just given the right triangle. Find out what x is. Find the missing side. Pretty straightforward here. We just have to make sure that everything's in the right spot here. My hypotenuse is the C. It's the last one, so that's the 9 here. I get x squared plus 25 is 81. When I move the 25 over, I get x squared equals 56. Now at this point, how do I get rid of something that is squared? Okay, how do I undo that? Well, I take the square root. Whenever I introduce a square root into the problem, meaning it wasn't there before, now it is, if I got rid of something that's squared, I have to use a positive and a negative here. So it's plus or minus 56, the square root of 56. Now, because we're talking about a length here, we're not going to use the negative answer. It's just going to be the positive square root of 56. Now, what is that? Use your calculator. We know it's between 7 and 8, between 49 and 64. So I get approximately 7.48 here.